endowed with a rich variety of mineral resources due to its varied geological structure. Coal is one of the important minerals which is mainly used in the generation of thermal power and smelting iron ore. Millions of years ago, dead plant matter fell into swampy water, and over time, a thick layer of dead plants lay decaying at the bottom of the swamps. Let us study about coal sample collection. From railway wagons, coal samples are collected by dividing the whole rake into sublots. The wagon numbers are selected according to random number table taken from Clause A 2.1 of BIS standards. Let's suppose that this rake contains 58 wagons. According to this table, we will have 6 sublots. Start with a number from 1 to 10, follow one direction. If the number encountered is greater than 58, go to the starting number and follow other directions till all the sublots have at least one number. The sampling spot is leveled for an area of 50 centimeters into 50 centimeters. 25 centimeters of coal is removed from the top surface of the selected spot. 50 kilograms of sample is collected from each selected spot. In case of road sale trucks, samples shall be collected from every 8th truck after the truck from which the first sample is collected. The top of sampling spot is leveled and 25 centimeters of coal is removed from the surface of the sampling spot. About 30 kilograms of coal samples shall be collected from the truck selected for sampling. Stones or shales of more than 250 millimeters size shall be removed. The quantity that passes over the conveyor in a day constitutes one lot, which need to be divided into a no of sublots for the purpose of sampling. For example, if the quantity to be passed in a day over the conveyor is 600 tons, then there will be 3 sublots of 200 tons each. While collecting the sample, the scoop should traverse the entire cross-section of the conveyor belt. Similarly, the coal available in the stockyard is also divided into a number of sublots. One point is chosen randomly for every 250 million tons of coal in the sublot for taking gross samples. Sampling is done of an area of a circle of 30 centimeters diameter and up to a depth of 1.5 meters. Similarly, in a coal face, samples are collected randomly from different points of the operational coal faces. Samples are sealed using tags and are transported in such a manner so as to make these tamper-proof. The samples are transported to the coal sample preparation room. This is a jaw crusher which can reduce the size of the coal samples to less than 50 millimeters. This is also called the primary crusher. Coning and quartering is a process in which the samples are divided into 4 equal parts. Then opposite corner quarters are rejected, while the other 2 opposite corner quarters are retained and mixed again to be crushed further. This jaw-type crusher can reduce the sample size to less than 12.5 millimeters. This is a roller-type crusher which can further reduce the sample size to less than 3.35 millimeters. The process of coning and quartering is again repeated, in which 2 opposite quarter corners are rejected and the other 2 opposite quarter corners are mixed again and passed through the pulverizer. The next stage of sample preparation is a very crucial stage because the stage prepares the laboratory-ready sample. The pulverizer is properly cleaned before operation because the leftovers of previous samples can mix with the present sample intended to be tested. The sample is now ready for testing in a coal analysis laboratory. The principle of calorimetry states that if there is no loss of heat in the surrounding, then the total heat lost by a hot body is equal to the total heat gained by the cold body. First, the empty crucible is weighed and tiered. Approximately 1 gram of coal sample is taken for analysis of gross calorific value. The weight of the coal sample is input into the software that controls the auto bomb calorimeter. The water will absorb the gases released post-combustion. If cotton thread is used for firing, it must touch the coal sample. The bomb is then assembled and it is ensured that the oxygen release valve is tight. The oxygen cylinder knob connecting the bomb is opened and the pressure is set to 420 psi. The water jacket is filled up to 2 liters of distilled water. The combustion vessel is placed in the jacket and then the jacket is placed in the bomb calorimeter. The terminals are then connected to the combustion vessel and covered. The rise in temperature of water is measured. The GCV of the sample will determine the grade of the sample. Let's learn about acid correction test. The water in the bomb has sulfuric and nitric acid, whose heat of formation is adjusted. The bomb washing are diluted to 100 ml using distilled water. Boiling evaporates carbon dioxide present in the solution. 10 ml of solution is pipetted and transferred to a conical flask for titration. The first titration is carried out against 0.1 normal barium hydroxide with phenolphthalein solution as indicator. 20 ml of 0.1 N sodium hydroxide is added and the barium sulfate precipitate is filtered. The next titration is carried out with 0.1 N hydrochloric acid with methyl orange as indicator. The calculation for acid correction test is done as shown. Let's learn about ash determination. 1 gram of lab sample, minus 212 microns, is taken in a dry weighted clean empty vessel made of silica or platinum. The coal sample is evenly spread out to prevent formation of lumps. The uncovered disc is inserted into the muffle furnace at room temperature. The coal sample is heated in presence of air to 500 degrees Celsius for 30 minutes. Then the temperature is raised to 850 plus or minus 10 degrees Celsius in 30 to 60 minutes and maintained for 60 minutes. After that, crucible is brought out from muffle furnace and allowed to cool fast on cold metal slab for 10 minutes and finally in desiccators. We can see that the coal sample has turned into ash. The ash percent is calculated using the formula shown. Let's see how moisture content in coal is determined. 1 gram of lab sample of minus 212 micron size is taken in a dry weighted clean empty vessel made of silica or glass fitted with cover. A hot air oven does not alters other macro constituents of coal. The sample is evenly spread to prevent formation of lumps. The silica or glass crucible is then put in a hot air oven at a temperature of 108 plus or minus 2 degrees Celsius for 1.5 hours. Thereafter the vessel with cover or lid is brought from hot air oven and kept in a desiccator for 20 minutes and then weighted and percentage of moisture is determined. If the sample is not put in desiccator, then it might absorb moisture immediately from surrounding atmosphere. The desiccators generally contain anhydrous calcium chloride or silica gel, also considered as best moisture absorbing agents. They are hygroscopic in nature and therefore they are used in desiccators to maintain a moisture-free environment. The moisture percent is calculated using the formula as shown. Let us now look into the procedure for assessment of stones. Stone assessment is done only for stones more than 250 mm size. Stone assessment is an important part of fuel supply agreement. According to the agreement, the purchaser shall inform the seller any incident of receipt of stones in any consignment immediately on its detection at the delivery point. The stones segregated by the purchaser at the power station end shall be assessed jointly by the representatives of the seller and the purchaser at the power station. The stones shall be loaded into trucks and weighed at the nearest weighbridge. If all the stones cannot be loaded into the trucks, then volumetric measurement can also be opted for. In the case study shown in this video, all the stones have been loaded into a single truck. Since the tare weight has already been recorded in the system, so, the truck is allowed to stand still on the nearest weighbridge and the final weight of the truck is recorded.